be able to solve that inequality, and you should be able to graph the solution set of an inequality on a number line. Alright, let's get started. When you are writing an algebraic expression, equation, or inequality that represents a real-life situation, that is called modeling. Okay, so when we write an equation from a word problem or an inequality from a word problem, we're creating a model of that word problem. There are some keywords you're going to use as part of your translations. Remember, we had keywords for addition and subtraction and the parenthesis words and that sort of stuff when we were doing the equations. So we'll use those. In addition, we have to have some keywords for our inequality symbols. So this inequality is less than. And that's pretty much the only way you're going to write that as part of a word problem when you're translating out of it. It is less than. Now the interesting ones are the ones when they have equals to. So this inequality is less than or equal to. Okay, but you will often see it in word problems as is no more than, or is at most. So if you're reading a word problem and you see one of these phrases, that's going to be a less than or equal to. So our greater than is pretty much the only way you'll see it is greater than. And finally, the greater than or equal to we'll have is greater than or equal to. Okay, but you are more likely to see is at least. So if you're reading a word problem and you see at least, we're talking about greater than or equal to, or is not less than. Okay, so those are just some key words that you should remember when we're translating our inequalities. So let's try a couple. Okay, so we have the product. So remember, the product means multiplying of 12 and some number. So I'm going to say, I'll write that as 12 and some number, is less than, so is less than, is this symbol right here, 60. So 12x is less than 60. Okay, so hopefully we're remembering what we did before break, and that will help us here. So we have, on the second problem, the difference of, so that means subtraction, twice a number. Remember, twice means 2 times something, and so we'll just use x for our number. And 4 is at least. So at least, here it is right here. That's a greater than or equal to, so I know we're going to use a greater than or equal to sign there and 40. So the difference between 2x and 4 is at least 40. Okay, we could go on and solve that if we wanted to. Right now we're focusing on translating. So let's go the other way. I'm going to give you the math and you're going to write it in words for me. So we have some division here. So we're going to say the quotient, this is one way, remember, and remember when you're doing division, you have to go in the order of a number and 4, oops, we'll spell 4 correctly, so stick a U in there. So now we're going to look, I have a greater than or equal to, so I can use one of these 3 phrases to indicate what's going on. I think I'm going to use is at least. is at least 7. Okay? And let's try one more. So we have 10 and we have less than. So really our only option is just to say is less than. The product of 3 and a number. Let's say that. 10 is less than the product of 10 and a number. Now, you know that's not the only way we could write that. That's just the way I wrote it here. You could have said 3 times a number. Oh, so, yeah, sorry. Product of 3 and a number. All right. So let's take a look on the back for some examples. So these are kind of some of our easier examples. We're going to do a little bit harder ones here on the back. All right. So you're going to place an order for acrylic paint. Each tube costs $3, including tax. Shipping and handling costs are $2 for the entire order. You cannot spend more than $20. What is the maximum number of tubes of paint that you can order? So let's see, I'm going to use the variable T for tubes of paint. I like to use variables that remind me what I'm talking about. So it is $3 times the number of tubes of paint. That's going to get the cost for the paint. But you have to remember, no matter what, you're going to have a $2 shipping charge. So we got to add that on to it. So $3 for each tube of paint plus the $2 of shipping. And I cannot spend more than 20. Now here you want to think, can I spend $20? Sure, I can spend $20 because I have $20. And so when we look on here, it says is no more than. So that's really what it's saying. So we cannot spend more than $20. All right, so there's our inequality. Let's go ahead and solve it. So we're going to subtract 2 from both sides. So I get $3 times the tubes of paint has to be less than or equal to 18. Divide by 3. And T has to be less than or equal to 6. So what we were working on previously, 6 is our magic number. It is included. And I want less than that, so I'm going to shade to the left. What does that actually mean then, though? It means the maximum number of tubes of paint is 6. So you can order 1, 2, 3, 4, 5, or 6, but you cannot order more than that if you only have $20. Okay, so here's a good example. You're going to define whatever variable you want to use. If you want to use X every time, that's fine. It just sometimes helps you remember to give it a name that's similar. You're going to solve it, you're going to graph it, and what does that graph mean? In this context, you can get no more than 6 tubes of paint. So let's try our next one. You're going to the fair. It's $5 for admission and 80 cents for each ride. Suppose you go to the park with $13. Write an inequality that represents the possible number of rides you can go on, and what is the maximum number of rides? Okay, so we want to write the model like we did here. We're going to solve it, graph it, and then say what the graph means. So I'm going to use the variable R for rides. I know it's 80 cents a ride. So it's 80 cents a ride. That's, I'm going to spend that money. But what other money did I spend? I also spent $5 to get into the park. So I got the ride cost plus the $5 to get in. And all the money I have is $13, so I can spend no more than $13. I can spend $13, but I can't spend more than I have. So it's going to be less than or equal to. So now we're going to go ahead and solve this. We want to get r alone, so we're going to subtract 5 from both sides. So I have 0.80r has to be less than or equal to 8. Divide both sides by 0.80, and r is less than or equal to 10. So we're going to graph that. Our magic number is 10. It's in closed circle, and I need to be less than that. So I'm going to shade to the left. Okay, what does that mean? That means you can ride no more than 10 rides. If you ride more than 10, you're going to be out of money. They won't let you on. All right, let's keep trying. All right, so your mom is going to give you $5 to spend at the candy store. You decide to buy some gum at 22 cents a piece. You want to have at least $2.50 left over in your piggy bank. So write an inequality that represents the amount of gum you can buy. So we're going to write it, and then we're going to find out how many pieces of gum we can buy. So when you go to the store, you went to the store with $5 of money in your pocket. When you spend money, that money is subtracted from your total. And the money you're going to spend is 22 cents per piece of gum. So I'm going to say G equals gum, okay? All right, so the money I had in my pocket minus the amount I'm spending on gum, and I want to have at least $2.50 left. So at least is greater than or equal to $2.50 left in my pocket, because that's the very least I want to walk away with. I'd like to walk away with more. So let's see what we've got. So if we're going to solve this, we're going to go ahead and subtract 5 from both sides, and I get negative 0.22 times the gums greater than or equal to negative 2.50. Okay, we're still solving for G, so we're going to divide by negative 0.22. We're dividing by a negative number, so that flips your inequality to go the other way. And the number of pieces of gum has to be less than or equal to, when you math this all out, 11.36. Okay, so we're going to graph it, and then we're going to talk about that. 11.36, it's included, and I have to have less than that. Now, you cannot buy 0.36 of a piece of gum. So really, the most you can buy is 11 pieces of gum. So you can buy no more than 11 pieces of gum. All right, and so we rounded down because you can't buy a partial piece of gum. You can only buy a whole, and if you go to 12, you've got too many and you won't have enough money. So 11 is the most you can buy. All right, here's a couple more. So we have a rectangle, so you know anytime they say a shape, you should draw it. The length is 9 meters. It doesn't matter which one's the length. And the width is x meters. For the area of the rectangle to be at least, so we know at least is greater than or equal to 36 square meters, what is the smallest value x can be? So area is length times width. So we have not length times width has to be at least 36. Okay, this is a nice one-step inequality. Divide both sides by 9. That means x has to be at least or greater than or equal to 4. So when we graph this, our magic number is 4. It is included. Numbers greater than 4 are to the right. So what that means is 4 is the smallest that x can be. All right. Hopefully you're starting to get a feel for some of these. What I want you to do is pause the video and you're going to find the perimeter. Remember, perimeter is adding up all the sides, and then come back and see how you did. All right, so let's take a look. They talked about the triangle, and they said the first side is 21. So I drew a triangle, labeled one side 21, the other side was 12 feet, and the third side was 2x minus 4. So I labeled all my sides. To find the perimeter, you have to add up all three sides. So I set it all up to add up the three sides. Can be no more than, which means less than or equal to 65. And I solved it out and got that x is less than or equal to 18. So that's what's graphed right here. 18 is included, so we had to close circles, and less than is to the left. So what that means is 18 is the largest that x can be. So say you had a bunch of fencing, and you had 36 feet of fencing, and you knew that the length of this side, and you're trying to figure out what's the most that can happen with this x on this third side. Well, that x can be no more than 18, or you're going to run out of fencing. You're not going to be able to get your fence to connect all the way around. All right, so here's our last one. It's a little bit different, so I wanted to save it to go through with you. So we have Carrie, and she's a waitress. She earns $300 a week plus a 20% tip on the cost of each meal she serves. So when you go out to eat, you order your food, and at the end of the meal, you tip your waitress a percentage for her service, okay? And so she earns a 20% tip on the cost of each meal she serves. What is the least amount of total cost of meals she serves in order for her to get at least $500 a week? So Carrie needs $500 a week. Maybe she's got rent on an apartment, or maybe she's got a car payment, or I don't know. You know, she just needs $500 a week to make it. So no matter what, just going to work, Carrie earns $300. Okay? I'm going to use C for the cost of meals. In addition to that $300, so we're adding, she gets 20%. So 20% written as a decimal is 0.20. 20% for the cost of meals. So 20% times the cost of meals will give her her tip amount total for the week. And she needs to earn at least, remember, at least is a greater than or equal to $500 a week. If she's going to make all her payments, that's what she's got to earn. So now we can solve it. So we're going to subtract 300 from both sides, and we get 0.20c is greater than or equal to 200. Divide to get the c alone, and the cost of meals has to be at least $1,000. So she must serve $1,000 worth of food if she's going to make enough money each week. So we have $1,000. It is included, but if she made more, that'd be great. That'd be even better for her. So for each week, the total cost of meals must be, let's go with that, at least $1,000. And that shouldn't be too hard to do, because if you think about, you know, if a meal is $15, $10 to $15 each, over the course of a week, you should be able to serve $1,000 worth of meals. All right, you're going to work on questions 1 through 6, and I'll see you in class.